Here we are, back on notes, page 16. The top we did already, algebra with fractions. So let's scroll on down to the bottom. Woo, there we go. How do we estimate lengths, masses, and times? And we've been getting at this a little bit. We had a personal SI lab, so you got some sense of your body parts, lengths, masses, times. And we're starting lab 1-4, and we'll also have a little bit of homework on this stuff too. So lab 1-4 is going to have you make estimates, and really there are tough questions, meaningful questions in this world that you can't really have answer, an answer, the answer. For example, what if you were faced with this question? How many red blood cells are in your body? Was that important? Sure it is. Matters for a lot of things. Oxygen uptake, medications, all sorts of things. However, what's the answer? Well, you can't get an answer. You can't take every person's blood out and count all the red blood cells, so how are you going to know? Or how many cans of paint do you need to paint your back porch red? I know it says something on the can. Listen, sure it does. Yeah, one can will cover whatever, 400 square feet. Sure it does. If you ever try it, though, it never quite works out that way. This is a problem that also you need an answer to because you have to know. A can of paint is $50. How many are you going to buy? So these are questions that we need to answer. However, the best you can do is estimate. But estimate does not mean blind guess. Estimate is a sensible guess. There are ways to figure this out. And one way we'll track the word estimate is with that phrase we learned before, that concept or that idea really of order of magnitude. And the reason we do this is because there is no simple, exact answer. So we always have to start with a reference item or a conversion factor. The reference item has been what I've been calling the OG. You got to look at the scenario and say, what are we starting with here? We got to think of something. And then you have to start making some conversion factors. So here, here's a couple examples, a conversion factor. You might say 1 gallon of paint covers a room. Okay, well, then you can think of how much area a room is, and then, well, how much area is my deck, etc. A red blood cell, if you know the size of one, roughly its diameter, well, then you can perhaps scale up, well, what's the diameter of a blood vessel, and how many blood vessels are there, etc. You might be able to make a decent estimate. So here, there's some common items we learned about from Lab 1.3 from Personal SI. This list is by no means exhaustive, but this list will just help you get some ideas of perhaps estimates or conversion factors that you would like to use. So let's look at these. Up here we have just numbers. Now these will represent magnitudes. We got 100, which is 10 to the 2. Of course, that's order of magnitude 2. We got 10, we got 1. Order of magnitude, of course, is 0 here. 0.1, 0.001, or 0.01, 0.001. So that's tenths, hundredths, thousandths. Now, of course, you can go beyond this. You can get bigger, you can get smaller. And to turn these into magnitudes, we then have to hook them up with the item we're talking about, whether it's a length, a mass, or a time. So let's color code. Lengths will make red, mass will make green, times will make blue. So let's look at a couple of these here dandies. Okay. Do we know anything that's roughly 100 meters in length? Well, yeah, we got like the football field. We got the track straightaway. Anything else? Let's see. Let's thin this out a little so we can. Oh, it already is. 100 meters is like 1,000 feet. No, sorry. 100 meters is, let's see, 300 feet. Thinking crazy over here. Too much metric. 100 meters is like 300 feet. 300 feet is like 30 stories. So that's like a tall building, maybe a city apartment building. NYC apartment building height. Those are all things that are around 100 meters. What about the 10 meters? 10 meters, that's like 30 feet. That's more like the EHS height. That's like between the yard markers on the football field. That's the big yard markers. There are things about that. That's like, it's not, the width of our classroom's a little smaller and the length's a little bigger, but basically like a classroom length. We have a particularly stretched room. All right. How about 1, which is 10 to the 0, order of magnitude 0 lengths? That's 1 meter. Well, your leg A person themselves. A person is usually around 1.5 meters, so that's close to 1. Your leg, a person, arm, obviously a meter stick, plenty of things. All right, how about 0.1? Ooh, this is what we call decimeters. So 0.1, that's really like your middle finger length. That could be like a can height. It could be like a straw or a pen. All right. How about 0.01? That's centimeters now. Centimeters. So centimeters, of course, what could we have? That's we actually did that. That was your pinky thickness. What else is about a centimeter? Anything small, like maybe your fingernail. That could be like a small coin, like maybe a penny. What else? Now, pennies actually are bigger than that, but there are some coins in foreign countries that really are. Let me think. I've seen some. Maybe Aruba might have a little coin. Curacao, I know, has a little coin, a little tiny coin like this. Forgot what it's called. That thing's definitely like a centimeter. And then millimeter over here, that's 0.001. So this is millimeter, centimeter, decimeter, meter. And then you can have deca and hecta, but we don't really talk about those. Okay, over here, millimeter. What would be millimeter? That's like like your pencil or pen line when you draw it out on paper. Millimeter. You know, if you that's like your nail, your fingernail thickness. So that's like the thickness of your fingernail. I mean, if you had long, jagged fingernail, you dug it into the table and could scratch a line with it, that line would be like a millimeter thick. And so, we could also get up to kilometers. I don't even have it listed here. Kilometers or something like miles. So kilometer is like a long walk or a few kilometers. All right, let's get into some masses. 100 kilograms. Okay, that's a person, an adult. Actually, the standard 100 kilograms was Fletcher, Mr. Fletcher. So when I say a person, an adult person, little kids are generally not that. 10 kilogram, that's more like 25 pounds. That might be a weight at the gym. That could be a toddler. All right, keep on going. 1 kilogram, that might be a book. That could be, let's see here. Let's say something like a stapler, but not really. Maybe like we got the heavy duty hole punch. That's probably closer. Book, big hole punch. Or, of course, that kilogram that we can't really hand it around, but you'll see shiny looking thing. It fits in the palm of your hand, good size. That's a kilogram. Over here, talking about a tenth of a kilogram. So, tenth of a kilogram, what could we have here? That could be like maybe like an apple, maybe like a baseball, roughly. Here, 100th of a kilogram. Now we're looking at 10 grams. That could be like a pen. Usually a nicer pen's got a little more mass to it. Things of that sort. You could have collections of items, but over here, this is just a gram, which is a very common one. 1 gram, that's like a paper clip. That's actually the mass of a dollar bill. Those two are pretty good measures of a gram right there. So, if you want 10 grams, you need a stack of bills, 10 singles, meaning the single dollars. All right, let's get over here. Times. What's about 100 seconds? That's kind of like, let's see. That's roughly, it's more than, but it's on the order of a minute there. What lasts 100 seconds? That could be maybe a good breath hold. No, 10 seconds is not a good breath hold. This is approaching 2 minutes, which is reasonable. You can all do that. Those times around 100. Maybe you can get like your heart a beat. Well, that's good. All right, 10 seconds. 10 seconds is probably how frequently between your breaths. If if you're relaxed, not when you're running. 10 seconds also could be, well, you could probably say the alphabet in about that. A, B, C, D, E, F, G, H, I, J. Yeah, that makes sense. You can do your ABCs in about 10 seconds. What was this you're supposed to do actually when you brush your teeth? That's like 100. That's brush your teeth. What are you supposed to sing? There's some song you'll sing twice. I don't remember which now. Twinkle, twinkle. All right. Over here, 1 second. That's like your pulse, how often your heart beats. People often count 1, 2, 3, 4 when they're playing hide and seek or something, usually on the order of 1 second per count. Here's a tenth of a second. That's about like a quick stopwatch double hit. You know, you do the click, click. This is also what we call human reaction time, is around a tenth of a second. It's actually a little more than that. But that means if somebody drops something, you try to catch it, or you see a ball coming at you, you got to get out of the way, or somebody runs on the road when you're driving. You can't react any faster than a tenth of a second. You're actually slightly slower than that. 100th of a second. Normal stuff is 100th or even 1,000th that you would experience. None really pop into my head real quickly. 100th of a second, maybe, I don't know, maybe like a flutter blink. You blink your eye real quick, you know, when almost like a twitch blink. That might be take 100th of a second, although that's probably off. It's probably slower than that. But these over here, we're getting to fast times. I don't know if there's any normal stuff because you don't normally experience that. Actually, my mistake. We do have something for the 100th of a second. Forget the flutter blink. How about this? Your slow-mo video frame rate. So a regular slow-mo video might do it in 60 or 120 frames per second. That means if you click, you're getting about a hundredth of a second per picture. We'll learn about frame rates of videos later. 1,000th, this would be one of those like high def, truly high def, like not iPhone, beyond iPhone. High def, like big money, slow-mo video. That's like some of those you see on YouTube where people get balloons smashed in their faces or whatever else. Okay, cool. Then this may help you a bit. In fact, knowing some of these things is useful for you to have a rough idea of what it is that, these different magnitudes actually mean. By the way, since I should have put it on here. We got the kilometers. How about the kilograms? You know, if you had 1,000, that would actually be like a car. This was 1,000 meters. 1,000 seconds. Didn't leave you a column for it. 1,000 seconds. What's that? Like 60 seconds a minute. So you got 10, another. So you got like 16 minutes. What would happen in that time? You could do like a run until you're tired, unless you're a trained runner. You run for 1,000 seconds, you would probably get tired. There you go. Good. Okay. Enjoy.